Well, good afternoon, everybody. Happy Wednesday. Today's online class was another technical issue. This time it's all my fault. The software I was using that I went to record, I messed up and I ended up putting just my face on the entire video until afterwards I realized that was the case. So those of you who joined me on the live Teams meeting, you saw me do it live, and now I'm going to be doing it again. I won't actually be typing the code. I'll just be showing you the sections of code I went over in today's live class. Alrighty, everybody. Let me just make sure. Looks right. Okay, good. So today, off our website, the agenda for today is to look again on continuing looking at the collections unit, which includes, you can look at the videos of me teaching it in the past, the presentation, the GitHub example, the unit review sheet, and the assessment page. You can also take a look at last week's video of what we did in collections last week, if you go back a week. So just to take a look at all that, this is last week's video, where also we had some technical issues, but I did not cover everything there on that video from last week. The collections assessment, we won't have time to get to today, but it's ready to go. The unit review would be in preparation for a test that we're not going to have. We're not going to have the test in collections because of school closure, but you do have the sheet as a reference, a quick look, if you need to just sort of quickly look at what collections are and linked lists. For the example, you can go and download the entire example right now as it was from last week, or if you wait a little bit till later today, you'll have the code with the stuff I'm going to do now, including comments. So the GitHub examples there. The collections video set is all the videos of me teaching the collections unit in class, which is more than just the example, is me going over all the specific content in the presentation and the concepts, writing them on the board and doing it the way you would traditionally done in a class. This is a big unit like the last unit, so there's a lot of concepts there. Then, of course, the presentation, the meat of the matter. Last week, we started our example and took a look at collections, and we went through the content of the example up to that point, which means we took a quick look at linked lists. We made what's called a node class. That was done last week. We completed the node class. We started the linked list class. We wrote a couple different methods to add to the front and add to the back. Okay, so that's where we're at. Here's that example. Okay, so the node class, now you can get it with comments, stores some data and a link to the previous node and a link to the next node. The data is a generic data type using something from our last unit. This makes the collection and the linked list a lot more flexible. You can use it with literally anything. So what we do in class in this example is something you can directly bring into projects now and in the future. It's what's called a self-referencing class. It's a node that makes reference to another node, next and previous. We wrote 3 constructors, 3, maybe 4, where the data, the next, and the previous are assigned from the parameter to the property. And then we used other constructors, which made a neat call to the other constructor by using this in a unique way. We overrode the toString method, we overrode the equals method, and within the equals method was the first example of us using casting in a strange way. So the object parameter is cast into a node object. You'll see that come up again today. So that strange casting. You saw us override the clone method and the finalized method, which was a neat method I mentioned. This is a method that we didn't override in the previous unit, which is when an object is destroyed or deleted. It cleans up all the memory it uses or the garbage that the system defines it as. And that's something we did. So if a node is destroyed, this is the code it goes to wipe it out. Also, real quick in the, we'll just go with that. And then from the node class, we started writing the linked list class, which is a collection of nodes linked together. Okay. The linked list also uses generics because it's using nodes. It has 2 references. One node references the head of the list or the start, and one node references the tail of the list, or the back. It also uses an integer to keep track of the length of the list, which is the number of nodes. And later on, we'll be using a constant called not found. So I'm just putting that in for now. You'll see where it's used later. Our constructor just wipes out the linked list using finalize again. So the same thing we did in the node class, finalize wipes out the content of the linked list. Okay. We wrote two little simple methods, isEmpty and size. IsEmpty uses a neat little piece of code to compare length to 0, which obviously is true or false. Either the length is 0 or it's not. And that's what it returns, a Boolean. So it's either empty or it's not empty. And size is a accessor method, which gives us the length of how many nodes, but doesn't allow you to change that variable. So you can access it, figure out what the length is, but not mutate it, not change it. Then we wrote two complicated methods to add to the front and add to the back of the linked list. I'm not going to go through all the detail on those, but you can now look back at last week's video or read the comments along the side here, which now outline the specifics of what's going on in each line of code here as I tried to explain it in the comments. Okay, so the first couple methods we're going to write today are actually a few little simple private methods at the bottom of this linked list. So the first method we wrote was a private method called inRange. And what it does is it checks an index number to see if it's inside the linked list. This is something you don't get with arrays. Like with an array, when you have an array, you have all these index spots throughout the array. And it starts at 0 and then 1 and then if you try to access a spot like spot 6 right here, it would be out of range. If you try to spot like -1, it'd be out of range. So this method returns true or false, is it in range? So it's a feature that exists in arrays that we're building into our linked list to make it so that that error that we have with arrays doesn't come up. All right, so what does the code say? Well, if the linked list is empty, then there's no number that could be in range. So I return false. If it's an empty list, there are no valid numbers. If the index is less than 0, return false. That's not a valid number. If the index is greater than or equal to the length, the number of nodes, return false. Otherwise, return true. So it's a simple little method that can check to make sure that the number we're working with is inside the range of the list. Okay. We then wrote a method called getFirstNode. This method is a protected method, which means, you may remember from the last unit, this is a method that can be accessed inside the class and can only be accessed outside the class if it's a child of this class. That's what protected means. And it's really simple. To get the first node, I just return the head. So this is also an accessor method. It allows you to access the head of the list, but not change the head of the list from outside the class. We also wrote getLastNode, which does the same thing, but it returns the tail of the list. So those are two accessor methods, getFirstNode and getLastNode, that allow you to access the head and tail of the list without changing them. And you can do that by classes outside the linked list class, as long as they're children of the class. Okay, and then we wrote one with a little more logic in it, a method called getNode using an index. It returns a reference to the node we're looking for. So if I'm saying, hey, give me the node at spot 4, it would give you that node. Okay? This is also a protected method inside the class. So this will be a helper method that I'll be using throughout the class to get nodes. First of all, if this index number is not in range, that's not a valid spot. So I have to return something. So I'm just going to return a null value, indicating that this is not a number that means there's a node there. Then I have two simple ones. If it's at index 0, index number is 0, then I just get the first node. And if the index number is length -1, Well, then I just get the last node. So those two are simple. It's either the first node or the last node. So I just get the first or last. Okay. Now, the last piece of the logic for get node is a little more complicated, as you can see down here. Okay. Now that it's not either the first or last node, I'm going to start off at the head of the list by using a reference called current. So it starts off at the head of the list. And then what I do is I take current and keep moving it along to the next node and the next node and the next node. So it started at the head of the list and it's going to keep going by using a loop starting at 0 and going up to this index number. So if I said go up to spot 4, it would loop up to spot 4, jumping to the next node each time until current finally sits at the node I was looking for, and then that's the thing that I return at the end. So this allows me, by getting a number saying give me node 4, I can get right to node 4. Okay, so these three protected methods and the one private method did not need to be tested because those are methods that don't require a test. But then the next method we wrote, get, is method we will be testing. The get method is a standard accessor method. It's what we take for granted when we're working with arrays, when we do something like this. X equals what's in the array at, say, spot number 4. So knowing what you know about arrays, what's happening here is I'm accessing spot 4 in the array and getting what's inside of the array there. So this index represents what I'm looking for, right? The index number I'm looking for. Obviously, we don't have to do this with arrays. With arrays, we don't say, hey, array dot get spot 4. I don't need to do that with arrays. I don't need to call a method because that's what the square brackets do automatically with arrays. Now that we're working with linked lists, we'll be using this method as an accessor instead of square brackets because we don't want to confuse it with an array. It obviously returns something, just like it returns something here. It returns whatever the generic data type for this linked list is. Okay, it only requires 2 lines. First line is an error check. If it's not in range, return a null indicating that there was nothing there. Okay? So unlike if I was trying to grab spot 4 in an array that only had 3 elements, it would crash. This linked list won't crash. It'll just return a null value because of our built-in in-range method, and I'm checking to see that it's not in range. But if it passes through that first line, then I can use my get node method to get me to the node. Then I say .data to get me the data, but I also need to put that little piece of code in there to make sure that the data is of type generic type T. So there's one last little casting that NetBeans requires you do. All right, so that's the get method. We wrote a little bit of code to test that. So to test the get method, I'm going to start my loop actually at spot 0 and go all the way up to list.size. So I'm going to get each index number all the way up to the end of the list, okay, by getting it, storing it in an integer, and then displaying the number and the integer itself. So let's test that. And here you can see it's getting, well, you can see 2 things, right? Like here's the actual list. So when I get spot 0, right here, it's a 0. If I get spot 9, which is right here, it's a 7, right? So it's working. And all the numbers in between, right? Like it's getting every spot. But now I'm going to go and test this beyond the edges of the list. So I'm going to go to 0 minus 1. That's 1 in front of spot 0. And I'm going to go to size plus 1. So I'm going to go beyond the edge on that side as well. And let's see what that looks like. Okay. So here now you can see it's not crashing. It's returning a null value. And when I go to spot 10 beyond the edge of the list, it's returning a null value. This is not something that would work with arrays. You would crash there. Okay? So that's our get method. The next method we wrote after get was set, which is a mutator method. Okay, so the set method, which is a mutator method, which means it's changing this spot. And what's it changing it to? Whatever this new piece of data is. Now in arrays, we wouldn't do it this way. In arrays, we would have gone, okay, go into the array at index number 4 and set it to be this new number 17. That's how we would do it with arrays. 17 would be the data that I'm changing it to. 4 would be the index number. So change spot 4 to be a 17. So that's what our set method is going to do. In addition, it's going to return true or false. Was this method successful in completing its task? The first 2 lines are some errors that would have been unsuccessful. If it's not in range, I just return false. This is not a valid number to do. If the data that I'm trying to put inside of it is a null, false, I can't do that. Then the next 2 lines would complete the task and return true that I was able to do it. First thing I do is I use a node reference called current and I get to that index by using getNode again. Remember, it's already checked that index and stuff. And then I just go into current's data and assign it the same data as the parameter right here. So it sets the data to be that. Okay, so then we tested our set method. To test our set method, okay, what we did was once again, and this time I'm just going to directly set it beyond the edges. Okay, so I'm going to go to the +1s on both of those beyond the edges. I created an integer. In this case, I'm just going to make the integer I. So at spot 0, it's going to be a 0. At spot 1, it's going to be a 1. It's pretty simple. I'm going to set that index number to be that integer by using my set method for that index to that integer. And because it returns true or false, I'm going to output that true or false value right inside here, inside of these outputs. So I'll show what I'm setting, I'll show the list. We should be able to see everything in the output of this test method. Okay, so here we go. Tried to set spot -1 to a -1. Said, no, we're not doing that. There is no spot -1. Similarly, if I jump down to the bottom and tried to set spot 10 to a 10, it's like, no. There is no spot 10. But the rest of it was okay. It was able to set spot 0 to 0. Notice it's a 0 now. It was a 2. It set spot 1 to a 1. Notice it was a 4. Now it's a 1. So it's actually mutating this list. And you can see here by the end here, it's just 0, 1, all through 9. It actually set each spot to a new value. And so that was our set method. Okay? We referenced the notes, how the in range, get first node, get last node, get node, toString, we already did. Methods were all done. Okay, the next thing we did in our linked list was we went back to a couple methods that were sitting there waiting for us to fill in. One of which was our clone method. Okay? And we want this clone method to make a duplicate copy of our linked list. So to do that, on the first line, I created a new linked list that I've named that. In a minute, you'll see kind of why I called it that. At the end of this method, I return that. So it returns a linked list, a brand new one, of the same data type T. Then what I do is I use a for loop to loop through this linked list. Notice there is a difference between this linked list and that linked list. This is the linked list I'm in. That is the new one. And I pull up the length. Okay. And then to that linked list, I add what I get from this linked list. So this and that is used together. Now, actually, when I put this, I said add back. But we then wrote a method called add. So maybe I'll pause for a second and show you what the method add looks like. The method add is a wrapper method. It doesn't like date Kim Kardashian or anything like that. What a wrapper method means is it hides another method that's being called. The other method is called add back. So sometimes I don't want to say add back, add back, add back. So instead I've just shortened it to just the word add. It still returns a Boolean, so it just calls upon the other method. There's an argument that then maybe add back should be made a private method, so it's hidden. And you could certainly do that as well. But I'm just going to use add back as the call there to use it for cloning. All right, so we're going to test that. So we're going to test the clone method. All right, so to test our clone method, we're going to make another linked list called linked list 2, also a linked list of integers, and it's a clone of list 1. And then we just outputted what both lists look like, list 1 and list 2. So let's see that. They should be perfect clones of one another. There they are. List 1 and list 2 look exactly the same. But then this was a good chance to test a method we did last class. Okay, our finalized method, where we wipe out one linked list. I'm going to wipe out list 2 and then output the two of them. So after I've cloned them, then I wipe out linked list 2 using finalize. And as you can see, they were clones right here, perfect clones. And then I cleared out list 2, but list 1 remains untouched. So that was a good chance to do that. But you may notice as I jumped around there, we also wrote a different method as well. We took the time to write the equals method. The equals method, which was already sitting there waiting for us to work on, checks to see if one linked list equals another. So it returns true or false. The parameter of an equals method, if it's done properly, is always an object. So on the very first line of this method, we cast, here you can see a casting taking place. That's why the round brackets are there. Our object into a linked list of data type T. I've once again called that linked list that. So that linked list. Okay. Then on my first line, I check this size and that size. If they are not equal, then they are not equal linked lists. That's an easy one. If two linked lists, like one's size 10 and one's size 100, they're not equal linked lists. Then to do the rest of the code, what I've done is I'm essentially going to go through every node in each list, and if it makes it through all those nodes, I will return true that they're equal. But to do this, I make a node current 1 and a node current 2. One comes from this, one comes from that. So from this linked list and that linked list. I get the first node of each of those. So I start at the front of the list. Well, current 1 is not a null. I could have easily put current 2 here. It doesn't really matter because they're both the same size. Inside the code, I move each node to the next node, like I did in previous code. Current 1 equals current 1.next, current 2 equals current 2.next. And finally, I use an if statement. If current 1 does not equal current 2, if they are not equal, then we can stop right here and return false. Somewhere along the two lists, I found two nodes that are different. And this relies on the equals method of the node class. So it was something we built last class to automatically do that. And so that allows me to check to see if two linked lists are equal. So to test that, I'm going to use the equals method before I change list 2. So right after cloning, I check to see if they're equal. And then I'm going to test it again, the equals method, after I change list 2. So here they should be equal, and here they should not be equal. And let's see what the test gave us. So the test results were that it was true right here that those are two equal linked lists. List 1 and 2 are equal. But then after I clear out the second linked list and make it empty, now the test says that they are not equal anymore. Okay? And I certainly could go further in my testing, but I thought that was a pretty good test just to quickly test the equals method. Okay? All right. Then I'm going to do something weird, and you'll see kind of why later. I'm going to clone linked list 1 into linked list 2 again. So now linked list 2 is a duplicate of list 1 again. Okay, I don't need to repeat that. Because of what's coming next, the last 2 methods we wrote today were some complicated methods. Okay, so we wrote equals, we wrote clone, get first, get last, get node, and in range. Okay, we also wrote get and set. We wrote a simpler version of add. But now what I want to look at is a method called add after that we're going to write here. Okay? The add after method is a little bit more complicated. As you can see, it's got quite a bit of information in there. But let me back up and kind of give you some context for what add after is about. Okay? So what the add after method is supposed to do, okay, is it says, okay, so let's say I had this number 2, which was the data I wanted to add. And I wanted to add it after spot 4 in my linked list. What this assumes is that we have a linked list, right? So we have a linked list of a bunch of nodes. Okay. Something like that. Okay. Each of these nodes has some data inside of it. So it's going to put a D for data. We can assume these nodes had index numbers, even though they really don't. It's not like an array where the index numbers are automatic. Let's just assume they do. 3, 4, 5, and 6. Okay. As well, these nodes are linked. Okay. So this node links back to this node. And they all go back, right? Like each node goes back to the previous node before it. And then this one links to null because there's nothing there, okay? As well, they link forward, right? So this node links to this node. They link to the next node, like that. That's what creates the linked list of these nodes chaining themselves together. And then this one at the very end links to null. That's the end of the list. This down here would be the tail of the list down here, right? The tail of the list would be down here. This up here would be the head of the list over here, the front of the list. That's what a linked list looks like. So now what we're saying is at spot 4, so right here at spot 4, I want to insert a node after this. So there's going to be a node created. Inside that node will be the data, in this case the number 2. And this brand new node will get put after these nodes. In order for it to do that, its next node that it's going to link to will be this one, right? That will be the node after it. Similarly, this will no longer be linked here. Its node, next node, whoops, will be this one now. So it'll go like that. Similarly, this will no longer be where this one links. It'll link here. And this one will link here. And that'll insert this new node after spot 4. That would be the idea, is we're inserting a node into the middle of a linked list. And so that's where this logic is going to go. All right, let's take a look at what the code says. All right, so the first thing it says is, if the data is a null, if that data right there is a null, no. Return false, we're done. If the index, this thing right here, is not in range, oh, no, we're done, return false. But if it can make it past these 2 lines and get down to here, it's going to return true, that it was successful in doing this. It'll also do this line to increase the length, the number of nodes, by 1. Okay, so that's what those 2 lines at the end are going to do. Now, this line right here says, you know what? If the index you're adding it after is at the very end of the linked list, which would be length minus 1, then just call a method I already have, which does this, called add back. It already adds it to the back of the linked list. So I don't need to go any further. I'm done at this point. And add back also increases the length by 1. So that would take care of that. But then these lines here, all the lines after that, are the lines that do the majority of the work of what's actually going to happen to add this into the middle area. First thing it does, it creates a brand new node. We already talked about that. It finds the spot, it gets to the node where the index asked us to go using current. So, to quickly draw this out again, I'm not going to draw the whole thing out again. But let's say this was index 4, this was index 3. There's obviously some more nodes going that way. This is now index, or node 5. There'd be more nodes going that way. Okay? So what it's doing is it's starting by making a brand new node. Calls it node. That's what happens on this line. Puts a piece of data inside of it. Whatever the data was that was passed right here. Okay? It initially sets this and this to null. Okay, so there's the new node. But then what current does is current gives you the reference of the node at that index. In this case, that index, let's say, was 4. So it gets me to spot 4 right here. So it's sitting here, and this node is right now linked here, and this node here is linked here. Okay, that's what they currently are. All right, so that's what those two lines do. Let's look at what these 4 lines do. Okay, so here's what it says. Node dot next, that's this reference right here, which is right now null, equals current dot next. Oh, well, you mean this thing over here. So I'm going to link to that one now. That's what I'm going to link to, not null anymore. Okay, done. Now it says current, that's this thing, dot next, that's this thing. So now I'm over here. Dot previous, so now it's talking about this thing right here. So it's like, okay, we're not going to be this anymore. What I want you to connect to is this thing called node. Oh, okay, I can do that. So now those two things are linked together. And that's done. Now what it says is current dot next. Well, that's this thing right here. So I don't want you to be this anymore. What I want you to connect to is the node. Oh, okay, I can do that. And then once that's done, what it does is it says node, that's this thing, dot previous. Oh, you mean this thing? The one that was a null? I want you to connect to the same thing called current. There we go. And then at the end of this method, current no longer exists, but look at the way the references are now. They are connected, and it has inserted this thing after what I was looking for before. So that's what those 4 crucial lines do to do the linking. It makes use right here of something called a double reference, like a double rainbow. It's a beautiful thing. All right, so that's a detailed explanation of what add after does. We then also wrote add before. Okay, but before I do that, let's test add after. So let's take a look now at what add before looks like. And actually, I think when I did this live in class, I did them in the opposite order. Not that it really matters. So add before is essentially the exact same code. What's different about it is obviously it's now called add before. But this line is exactly the same. This line is exactly the same. This line changes because now I'm going to add to the front when I'm adding before. And the index number I'm looking for is 0. I'm looking for the front of the list, not the back of the list. This line is exactly the same. This line is exactly the same. This line and this line are exactly the same. But these 4 lines do change. They become dual operations or reverse operations. So instead of next became previous. So instead of next became previous. Okay? Instead of next became previous. And instead of previous, it became next. So next and previous flipped, and the logic flips. And that's how we wrote add before. All right. To test this code, what I've written, okay, is a fairly long piece of code here. So let me just back this up and uncomment all this test. All right, I'll just briefly explain it. I tested a lot here, even more than I showed in the class. So to test add before, I show the list before I do anything. And then I'm going to test in the edges. So I'm going to add a 0 before spot 0. I'm going to also display the true or false, whether it was successful, and then I'll display what the list looks like right after I do that. Then I'm going to test add before, and what I'm doing here is list.size -1. I'm going to add it before the very last spot. So that's in the edges, and then I go just outside the edges. So I'm going to add before spot -1 and before the actual size of the list, which means it's going to go beyond the edge. And then I'm going to test random points in the list. So I'm going to use a random integer and a random index number to add it before that random index number, the random integer, and display what that looks like. And I'm going to do that a number of times in a loop. And I did the exact same thing with add after. Obviously, I changed this to add after, and I switched to list 2 for add after. Let's see what the test looks like. Okay, so here's add before. When I tried to add a 0 before spot 0, it said yes, I was able to do that. So here's the 0 added before spot 0. You can see that because here's the list before I did anything. So now a 0 has been put before spot 0. I tried to insert a 0 after spot 10. Okay, so wait a minute. Let me just go back and check that test. That looks a little wrong. Add before 1 0. There we go. Okay, let's see that again. I'm just misreading it. Add before spot 10 a 0. Wait a minute. Do I have this in the reverse order? What is add before? Oh, the data's first. Oh, that's why it's screwed up. So the data goes first, and then the index number. These are in the wrong order. It should be a 0 and then a -1. Sorry, guys. Let me just fix this on the fly. Okay. And then I'm adding a 0 before this. So add the data 0 before this spot. Okay. Let me go back and do it here. Add the data, which is 0, before this spot. That one won't matter because it's 0 0. Add a -1 before spot 0. Add a 0. Shoot, I had that right the first time. 0 before spot -1. Add a 0. Okay, so the data always goes first. So this is wrong. The integer should go before the index. My apologies. Okay, so that'll be the random insertions. This one as well, I gotta fix it up. So 0 goes before that spot. The 0 goes before that spot. The 0 goes before that spot. Whew. Okay, and then finally, the integer goes before the index. Let's see if that fixed it, and that'll be the end of the class today, everybody. All right, so adding a 10 before a 0 before spot 10. There we go. Adding a 0 before spot 0. Adding a -1 before spot 0. Well, that's not going to work. Adding a 0 before 12. That's not going to work. Okay, I'm going to rerun the randoms because it was giving me some weird randoms here. Okay, here we go. Adding a 3 before spot 7. So if you were to go 0, 1, 2, 3, 4, 5, 6, 7, it says it's going to try to add a 3 before that. 2, 3, 4, 5, 6. I'm not sure what's going on. All right, so I will make sure that code's all cleaned up. But you can see here the test should come out true. I'm going to not waste your time here on the rest of the video. That's where we stopped, and that's where I'm going to stop today's video. Thanks, everybody. Sorry for that little bit of a delay. I'll have this code all commented and up in GitHub shortly.